Hello coders, I welcome you all. In the last video, we understood the concept of n-grams. We already discussed unigram, bigram, trigram and combination of unigram plus bigram. Now in this video, we are going to perform a complete practical using real-world dataset for email spam detection using count vectorizer. Dataset link is provided in the description of this video. At the end, we will compare the performance of the model with unigram, bigram, trigram and combination of unigram plus bigram, and we will check which one is the best technique for spam classification. We will clean the text first. Also, we will remove unwanted elements, apply lemmatization, and finally convert our clean text into numerical format using count vectorizer. So let's begin step by step. First, we have to import all the necessary libraries. So let's first import pandas as PD, also numpy as NP. Let's import RE for regular expression. Also we require string library, and let's import Seaborn as SNS. Also matplotlib.pyplot as PLT. From sklearn.model_selection, let's import train test split. From sklearn.feature_extraction.text, let's import count vectorizer. From sklearn.ubias, let's import multinomial NB. Also from sklearn.metrics, let's import accuracy_score, and let's also import NLTK. Now from NLTK.corpus, let's import stoppers. From NLTK.stem, let's import wordnet lemmatizer. From NLTK.tokenize, let's import word_tokenize. I think we have imported all the necessary libraries. Now let's move on and let's download the NLTK resources. For that, we have to write NLTK.download PUNKT. This model is needed for splitting the text into words by this word_tokenize. Let's copy this. Let's paste it over here and here as well. Now let's change it to wordnet. So this wordnet is used by wordnet lemmatizer that we have imported over here to convert words into their base form. Let's change this to stoppers to remove stoppers, right? So here we are downloading stoppers. So using that, we can remove stoppers from our text. Now let's execute this cell. All done. You can see output is true. Means we have successfully downloaded all this. Now let's move on. Let's load our dataset as pandas data frame using pd.read_csv, and our dataset name is emails.csv. Let's assign it to one variable df is equal to this statement. Let's execute this cell. Now let's check first 5 rows of our data set. You can see here it contains 2 columns, text and spam, and this is our target variable. It contains 1 and 0, means it's a binary classification. 1 for spam and 0 for not spam, also called as hem. Now let's check shape of our data set. You can see it contains this many rows and this many columns. Now let's check for null values. Is null dot sum. You can see there are no any missing value in our data set. So now let's check for class imbalance. For that, we have to use our target column and value counts method of pandas data frame. Let's execute this cell, and you can see here there is a class imbalance. Many more non-spam emails than spam ones. So there are 2 ways to handle this data imbalance problem. First, using oversampling. For that, we have to use SMOT, synthetic minority oversampling technique, and using undersampling. In this video, we are going to use undersampling. So now let's move on and let's reduce the number of non-spam examples to balance the dataset for better performance. For that, let's use this spam column is equal to 0. You can see Boolean values, and we are interested in only true values. You can see dot sample to take random samples, and we have to make size of spam, this one, and also let's set random state to 40 to assign it to non-spam is equal to this statement. Now we have non-spam is equal to spam. that you can see. Done. So let's store spam as well. Spam equal to 1 and you can see spam messages. Let's assign it to spam. Done. So now we have same number of samples for non-spam and same number of samples for spam. Now let's concat using pandas concat function, non-spam and spam. Let's assign it to one variable, df balanced. You can give any other name as well. Let's execute this cell. So now this is our new data frame. Let's check the save. Done. Also, let's check using value counts. Now we have same number of samples for non-spam and spam because we have used under sampling. You can see now our data set is balanced. Both spam and ham messages are same in number, right? So let's check some of the messages first. df underscore balanced and text. Let's check 100 message. You can see here. Currently, I am randomly printing some of the text from our data set. This is at index 100. You can see here. It contains numbers, punctuation marks, and also it starts with subject. You can see 101. You can see all are having some numbers, punctuation marks, email addresses. Also, it starts with subject. So now we have to perform text pre-processing first. For that, we are going to define a text cleaning function that will lowercase the text, remove emails, URLs, numbers, punctuation. Also, it removes stoppers. Also, it will apply lemmatization. So this is crucial before applying any vectorization technique. So let's start. Before that, we have to set stoppers. So let's fetch different English stoppers from NLTK library that we have already imported. Set to find unique and let's assign it to stop underscore words. Done. Using this, we are going to remove stoppers from our text. Also, let's create instance of WordNet lematizer. Let's execute this cell. Now, let's define our text cleaning function. Here, we will pass our text from our data set. So first, let's make it lower. Let's assign back. Now, we have to remove subject from beginning. For that, we are going to use regular expression. So this will remove subject from our text. Next, we have to remove emails. For that, we have to write like this. Remove emails from our text. Next, we have to remove URLs. So again, for that, we are going to use regular expression. This regular expression will remove URLs from our text. Now, let's move on and let's remove numbers from our text. Again, we are going to use regular expression to remove numbers from our text using this regular expression. Next, we have to remove punctuation. So to remove punctuation, we are using this. We are removing punctuation from this string library, which contains different punctuation that you can see. If any of these available in our text, it will be removed using this. Now, let's tokenize our text. For that, we are using word underscore tokenize that already we have imported. Now, let's remove stoppers from our text. So here, we are removing stoppers from our text using stoppers that we have already imported over here. This one, right? After that, we are going to use lematizer that we have already imported to convert our words into their base form. As you know, we are going to use WordNet lematizer that we have already imported, and also here we have created instance of WordNet lematizer that we are using here. After that, we have to join our clean text and that we are returning. Let's execute this cell. All done. After defining this particular function, now let's apply it to every row in our data set to create a new column, clean text. For that, we have to use our balanced data set and text, and we have to apply this particular function, clean underscore text. This function will be applied to each and every row available in our data set. Let's assign back with name clean underscore text is equal to this statement. Let's execute this cell. Done. Let's check. You can see here our old text means unclean text and our clean text that you can see here. Subject, punctuation mark, these all we have successfully removed. And now we have our clean text. So now let's move on. Let's split our data set into train and test set. So df underscore balanced, and here clean underscore text. Let's assign it to x, our independent variables, and our dependent variable. Let's execute this cell. Done. Now let's perform train test split. X train, X test, Y train, and Y test is equal to train test split, our independent variables, our dependent variable, and we are setting test size to 20%, and again random state to 42. Let's execute this cell. Let's check. Done. We have successfully created our train and test sets. So now let's perform model training with different n-gram ranges like Unigram, Bigram, Trigram, and combination of Unigram plus Bigram. So now let's move on. So now first let's set our n-gram ranges. List of tuples Unigram or Bigram or Trigram and combination of Unigram plus Bigram. Also, we will store accuracy scores for this all into this particular list. Now for n-gram in this n-gram underscore ranges, let's print in proper way. Lesson. And now let's try with n-gram range and gram. I'm setting this just for better visualization. And let's initialize count vectorizer with n-gram underscore range that we have to set with this. Every iteration, it will receive these different n-gram ranges from here. First using Unigram, then Bigram, then Trigram, and combination of Unigram plus Bigram. And let's set it to one variable. And dot, we have to fit underscore transform with x underscore train. And let's assign it to x underscore train underscore vec. Same for test as well. Let's copy, paste it over here and test. And here also test. But here only transform. Now, and we are going to use this particular model, multinomial NB, which is good for text data. And let's assign it to one variable model. Then model dot fit. Let's train this on our train and y train. Let's perform model dot predict using x test. Let's assign result to y pred. Let's calculate accuracy score for every model, right? And we are going to store inside this particular list. Here we have to pass two arguments, actual value and predicted value by our model, which is available inside y underscore pred. Assign it to one variable accuracy, right? And we are going to store accuracy over here in this particular list. So we can compare at the end. Dot append and act. Also, let's print all the accuracies over here as well. Accuracy for n-gram, and ac colon 4f. So I think all done. You can see count vectorizer, fit transform, and transform on test. Here we have created instance of this particular model, multinomial NB. Here we are training the model. Here we are performing the prediction. Here we are calculating accuracy. We are storing accuracy in this particular list for every iteration for Unigram, Bigram, Trigram, and combination of Unigram plus Bigram. And also we are displaying on the console. So let's execute this cell. And here is some error. So here is the error. Oh, sorry, not this. We are fetching here one by one, right? So in place of this, let's copy and we have to use this one because we are taking one tuple at a time from this, right? Sorry for this. Now let's execute this particular cell one more time. Now it's working fine. You can see Unigram, accuracy for Unigram, Bigram, accuracy for Bigram, Trigram, accuracy for Trigram, and combination of Unigram plus Bigram. Also, we can add one more, Unigram, Bigram, and Trigram, right? So as per your requirement, you can add different combinations over here. Let's execute this cell one more time. You can see Done. Hope all of you are clear with Ngram. Now let's plot these accuracies of Unigram, Bigram, Trigram, combination of Unigram and Bigram, and also for the combination of Unigram plus Bigram plus Trigram using bar plot and using Seaborn. For that, here is the code. We are using Seaborn bar plot. Here we have to set as per this copy. Let's paste it over here, and also we have to add this Unigram plus Bigram plus Trigram as well, because just we have added this, right? Let's execute this cell. Here some overlapping, so I think this one still overlapping, so for that we have to use plt dot xticks rotation is equal to 45. Let's check. Now it's look better. Now let's change to 75. Let's execute this cell. I think it looks better, right? Also you can change as per your requirement. Now this look better, right? So you can change as per your requirement. But from this we can say that Unigram gave us the highest accuracy of around 98.72%. Second highest of Bigram 97.62%, that you can see here, and lowest by Trigram. And these two combinations are also good, right? So these both prove strong combo, right? But the best one is Unigram. So overall Unigrams alone perform the best, but Unigram plus Bigram and also Unigram plus Bigram and Trigram also prove to be a strong combo. I hope all of you are clear with how to use Unigram, Bigram, Trigram and combinations of Unigram plus Bigram plus Trigram in your project. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.